Welcome to online lecture series on Laplace transforms, lecture number 4. Let us first recall the Laplace transform of elementary functions which we have already derived in the previous lectures. L of 1 is 1 by s, that is Laplace transform of 1 is 1 by s. L of k is k times 1 by s, that is k by s. L of e power at is 1 by s minus a. L of e power minus at is 1 by s plus a. L of sin at is a by s square plus a square. L of cos at is s by s square plus a square. L of sin H at is a by s square minus a square. L of cos H at is s by s square minus a square. L of t is 1 by s square. L of t power n, where n is a positive integer, is n factorial by s power n plus 1. L of t power a, where a is a real number greater than minus 1, is gamma of a plus 1 by s power a plus 1. Now let us find Laplace transform of some functions. We'll start with finding the Laplace transform of the function e power 3t minus 2 into e power minus 2t plus sine 2t plus cos 3t minus 2 cos h4t plus 9. So let us consider the Laplace transform of this function. We have a linear property for Laplace transform. So let us apply linear property here. What does linear property say? Laplace transform can be separated under addition and multiplication, and a constant can be taken outside the Laplace transform. So this expression can be written as L of e power 3t minus 2 into L of e power minus 2t plus L of sin 2t plus L of cos 3t minus 2 into L of cos h4t plus L of 9. That is linear property for Laplace transform. So applying this linear property, we get this L of e power 3t minus 2 times L of e power minus 2t plus L of sin 2t plus L of cos 3t minus 2 times L of cos h4t plus L of 9. These are all elementary functions. So we know the Laplace transform of each and every function here. Laplace transform of e power 3t is 1 by s minus 3 because Laplace transform of e power at is 1 by s minus a, and in place of a we have 3 here. So 1 by s minus 3 minus 2 times Laplace transform of e power minus 2t is 1 by s plus 2 plus Laplace transform of sin 2t is 2 by s square plus 2 square, that is s square plus 4, plus Laplace transform of cos 3t is s by s square plus 3 square, that is s by s square plus 9, minus 2 times L of cos h4t is s by s square minus 4 square, that is s by s square minus 16, plus L of 9 is 9 by s because L of k is k by s. So this is Laplace transform of the given function. Next one is find the Laplace transform of the function t square plus 1 whole square. First we consider L of t square plus 1 whole square, and using a plus b whole square formula we expand t square plus 1 whole square as t power 4 plus 2t square plus 1. Now let us again apply the linear property for Laplace transform. Then we get L of t power 4 plus 2 times L of t square plus L of 1. We know that L of t power n is n factorial by s power n plus 1, where n is an integer. Here t power 4 in t power 4, 4 is an integer. In t square, 2 is an integer. So we apply the formula L of t power n when n is an integer is n factorial by s power n plus 1. In the first case, in place of n we have 4. So it is 4 factorial by s power 5. And in the second case, in place of n we have 2. So it is 2 factorial by s cube. So after substitution of the formula, we get 4 factorial by s power 5, that is 24 by s power 5 plus 2 into L of t square is 2 factorial by s cube. So multiplying 2 and 2 we get 4 by s cube plus L of 1 is 1 by S. Now after simplification, that is taking out 1 by S power 5, we get 1 by S power 5 into S power 4 plus 4S square plus 24. This is Laplace transform of t square plus 1 whole square. Next one is find the Laplace transform of sin t plus cos t whole square. So let us consider L of sin t plus cos t whole square, and we expand sin t plus cos t whole square using a plus b whole square expansion. Then we get L of sin square t plus 2 into sin t cos t plus cos square t. And we know that sin square t plus cos square t is 1, and 2 into sin t cos t can be written as sin 2t. Sin 2 into sin t cos t can be written as sin 2t. So now this becomes L of 1 because sin square t plus cos square t is 1 and 2 sin t cos t is sin 2t. Now again using linear property of Laplace transform, we can write it as L of 1 plus L of sin 2t. What is L of 1? It is 1 by S plus L of sin 2t is 2 by S square plus 2 square, that is 2 by S square plus 4. So taking LCM and simplifying, we get it as S square plus 2S plus 4 by S into S square plus 4. Next one is find the Laplace transform of sine h cube 2t, sine hyperbolic function 2t. Oh, we know that sine hx is e power x minus e power minus x by 2. Now in place of x, let us write 2t because we need sine h cube 2t. Therefore, sine h2t is e power 2t minus e power minus 2t by 2. So, to get sine h cube 2t, we raise to the power 3 on both sides. Then, sine h cube 2t is nothing but sine h2t whole cube, and sine h2t is e power 2t minus e power minus 2t by 2 whole cube. By using the expansion of a minus b whole cube here, what is a minus b whole cube? It is a cube minus 3a square b plus 3ab square minus b cube. In place of a, we have e power 2t here, and b is e power minus 2t. So if we substitute in this formula, we get a cube, that is e power 2t whole cube is e power 6t minus 3 into a square b, that is e power 4t into e power minus 2t is e power 2t plus 3ab square, that is 3 into e power 2t into e power minus 4t, that is 3 e power minus 2t, minus b cube, that is e power minus 2t whole cube is e power minus 6t. So this is sine h cube 2t. Sine h cube 2t is this. Now take Laplace transform on both sides. Therefore, L of sine h cube 2t is equal to L of 1 by 8 times e power 6t minus 3 e power 2t plus 3 e power minus 2t minus e power minus 6t. 1 by 8 is constant, so it can be taken outside the Laplace transform, and using linear property, we write it as 1 by 8 times L of e power 6t minus 3 times L of e power 2t plus 3 times L of e power minus 2t minus e power minus 6t. And what is L of e power at? It is s by s minus a, and L of e power minus at is s by s plus a. So applying that formula, we get 1 by 8, 1 by s minus 6 minus 3 into 1 by s minus 2 plus 3 into 1 by s plus 2 minus 1 by s plus 6. Now grouping these two terms as a single term and these two terms as another term, we get 1 by 8 times 1 by s minus 6, that is this term, minus 1 by s plus 6, this term, minus 3 by 8 times 1 by s minus 2 minus 1 by s plus 2. Taking LCM and simplifying, we get 1 by 8 times 12 by s square minus 36 minus 3 by 8 times 4 by s square minus 4. Again taking LCM, we get 48 by s square minus 4 into s square minus 36. There is alternate method to find the Laplace transform of sine h cube 2t, because we know the formula sine h3x is equals to 3 sine hx plus 4 sine h cube x. From this we can find sine h cube x. What is sine h cube x from this? 1 by 4 times sine h3x minus 3 sine hx. Sine h cube x is 1 by 4 times sine h3x minus 3 sine hx. Now in place of x we write 2t. Put x is equals to 2t here. Then we get sine h cube 2t is equal to 1 by 4 times sine h 6t minus 3 sine h 2t. So taking x is equal to 2t, we obtain this. Now take Laplace transform on both sides. Therefore L of sine h cube 2t is L of 1 by 4 times sine h 6t minus 3 times sine h 2t. If we use linear property on Laplace transform, this can be written as 1 by 4 times L of sine h 6t minus 3 times L of sine h 2t. What is L of sine h at? A by s square minus a square. Therefore L of sine h 6t is 6 by s square minus 36 and L of sine h 2t is 2 by s square minus 4. So after simplification we get it as 48 by s square minus 4 into s square minus 36. So we can either use this formula to find sine h cube 2t, or we can use the expansion of sine hx as e power x plus e power minus x by 2. In any method we can reduce its Laplace transform. So let us go to next problem. Find the Laplace transform of cos square 3t. We know that cos square x is equals to 1 plus cos 2x by 2. Now in place of x, if we write 3t, right, x is equals to 3t in this formula, then we get cos square 3t is equal to 1 plus cos 6t by 2. So take Laplace transform on both sides. Therefore L of cos square 3t is equal to L of 1 plus cos 6t by 2. The denominator 2 can be taken outside, and using linear property we get 1 by 2 times L of 1 plus L of cos 6t. L of 1 is 1 by s and L of cos 6t is s by s square plus 6 square, that is s square plus 36. Taking LCM we get 2s square plus 36 by 2s into s square plus 36. So this is L of cos square 3t. Find the Laplace transform of root t. F of t is equal to square root of t. We know that Laplace transform of t power n when n is an integer is t power n plus 1 by n plus 1. But when n is a real number like here, that here n is 1 by 2. Laplace transform of this function L of t power 1 by 2 is gamma of a plus 1 by s power a plus 1. Here a is 1 by 2. So we will apply this formula here. So consider L of root t, that is L of t power 1 by 2. So by above formula it is gamma of 1 by 2 plus 1 by s power 1 by 2 plus 1. Gamma is a gamma function, and we have a very interesting property for gamma which states like this: gamma of n plus 1 is equals to n into gamma of n. So we will apply that formula here, where n is taken as 1 by 2 here. Therefore gamma of 1 by 2 plus 1, using this formula we get it as 1 by 2 into gamma of 1 by 2. So this is 1 by 2 into gamma of 1 by 2 by s power 3 by 2. But gamma of 1 by 2 is equal to root pi. Therefore this is 1 by root pi by 2 into s power 3 by 2. Therefore Laplace transform of root t is root pi by 2 into s power 3 by 2. So these are some practice questions to you. Find the Laplace transform of each and every function given here. There are some hints also provided to you in terms of the formulae. You can use those formulae, and these are very simple. You can easily derive Laplace transform of these functions. Give a good try. Okay, if you have any doubts you can contact me. Thank you.